Now we have another question which is based on composite body method. We've been given that a square hole is made out of a circular lamina, which means we'll divide this question into two halves. One is figure 1, the circular lamina, and figure 2, which is the square hole. We'll individually find out the center of mass of these as x1 comma y1 and as x2 comma y2 for figure 2. Okay, so for the figure 1, we know that the center of mass of the circle will be the, which should be writing as a comma 0. Center of mass of the circle will be the geometric center, which actually is the x comma y coordinates of its center. Now, since the center of the mass of the figure 1 represents x comma y and not x1 comma y1, what is x1 comma y1? x1 comma y1 is the center of mass of figure 1, yes, but with respect to origin. Now the origin according to this question is placed like this: x-axis, y-axis, this is the origin. So origin actually overlaps, origin 0 comma 0 overlaps with the center of the circle. Therefore x1 comma y1 will be equal to 0 comma 0. To go up one step further, this point, let us say this is A, would be a comma 0, and the point here B, this point here B would be 0 comma a. Okay, now what about the second figure? The second figure is a square. We know center of mass of a square is L by 2 comma L by 2, which is half of length and half of width, which means it comes to around this point. The given in the question that this distance is d, therefore center of mass of figure 2, which is not x2 comma y2, it is x comma y, will be at L by 2 comma L by 2. But since x2 comma y2 represents center of mass of a figure 2 with respect to the origin, x2 should be equal to, x2 here should be equal to this distance, which according to the question is equal to d. Therefore x2 comma y2 becomes d comma, what is y2? Since this point is on the y-axis, y2 is 0, the value of d is given to us as a by 2, so x2 comma y2 becomes a by 2 comma 0, right? So we have two values now, which are 1, x1 comma y1 equal to 0 comma 0, and 2 for the square, x2 comma y2, which is equal to a by 2 comma 0. Now using the composite body method, now when I say a composite body, what do we mean? So we had a combination of, give me a second, we had a combination of two figures, right? We had a combination of two figures, one which is the circle and the square. So the circle represents this larger figure like this, right? And what did we remove out of it? We removed the square out of this. And when we remove the square, what we get is a hole there, right? And this hole subtracted from the complete circle gives the composite body. So center of mass of this composite body, since it is subtraction, would be center of mass of figure 1 minus center of mass of figure 2, which is m1x1 minus m2x2 by m1 minus m2. Now the next question comes up, what is m1 and m2, because it is not given in the question directly. So to analyze that, we need to consider one specific phrase given in the question, which is uniform circular disk. Now what does it mean when the mass is uniformly distributed? It means that sigma of the circular mass should be equal to sigma of the square mass. What is sigma of the circular mass? Say it is sigma 1, square is sigma 2. Mass density is mass by area. Mass density is mass by area. M1 by A1 should be equal to M2 by A2. What is A1? Okay, so from this expression, M2 is M1 by A1 into A2. What is M2? M2 here is M1 by A1, which is area of circle, A2, area of square. Area of square is length square, which is A by 2 square. Area of square is pi r square. R is A, so that becomes pi A square. So this further becomes m1 into a square by pi a square into 4. A square by a square is 1. So this can be written by taking 4 pi to the RHS. m1 is equal to m2 into 4 pi. So center of mass of figure 1 minus center of mass of figure 2 was m1 x1 minus m2 x2 by m1 minus m2, where we have the relation m1 is equal to 4 pi into m2, which means this m1 can be replaced by 4 pi m2, m1 can be replaced by 4 pi m2, and since we had the values as x1 comma y1 is equal to 0 comma 0 and x2 comma y2 as a by 2 comma 0, we can say that x1 is equal to 0, so x1 is replaced by 0, which means this phrase now gets eliminated. So all what we have is minus m2 into x2, which is a by 2, by 4 pi m2 minus m2. I can divide this complete equation by m2, which gives us m2 by 1, m2 by 1, m2 by 1. So minus a by 2 by 4 pi minus 1. 4 pi minus 1, pi is 3.14 into 4 is 12.56. 12.56 minus 1 is 11.56. This becomes minus a by 2 divided by 11.56 by 1, which is minus a by 2 into 1 by 11.56. 11.56 into 2 is 23.12. So approximately this is minus a by 23, and therefore if the distance of the center of mass is minus a by x, when you compare these two values, the value of x can therefore be approximated as x is equal to 23. Okay, so that's the calculation here, and the most important point here would be to understand the calculation of center of masses of these two figures.